So this is a susceptibility weighted image, and it's used to look for small areas of hemorrhage. And small areas of hemorrhage will look really dark on this image, like little dark spots maybe here and here. But the majority of brain injuries aren't that severe, right? Most people who hit their head playing rugby, it's not the same impact as being in a car accident. And the very mild injuries sustained in those types of concussions, you just don't see any findings on a traditional MRI.
In New Zealand, concussion is a very common injury. Here on the eastern cape of the country, in a small town called Gisborne, there's a dedicated group of researchers who are trying to find a way to properly diagnose and monitor concussion recovery with the hopes of achieving better patient outcomes with the use of some quite innovative technology. Now, Dr. Samantha Holdsworth from the Mātai organisation, whom I'm about to talk to, she's heading up this research. Dr. Samantha, hi, lovely to meet you. How did this research and study and project come about?
Well, this is part of a really large concussion study, and the idea here is that we're trying to come up with better ways of detecting concussion so we can better manage and treat it. What we're doing is we're adding on a whole lot of different types of advanced MRI imaging, and so what we've done is we've developed, alongside our colleagues, a method of amplifying the way that the brain moves so you can actually see the motion of the brain as it beats with the heart. If someone has a concussion, there might be some brain swelling that might happen as a result of the concussion. This is a person that was scanned initially, eventually had a concussion, and then we scanned them again. So that's just one of many of the advanced methods that we're trying to use to build up a better picture so that we can diagnose it.
Right, so Mikey, these images on the left here are the clinical images we took off the scanner. So these images have now been post-processed by Dr. Mātai. And just to give you a sense of what they look like, there's a lot more information on these images than there are on these images. And Dr. Marin will be able to step you through what they can show you.
Diffusion MRI, we're actually looking at the movement of water molecules in the brain. So you know that the whole body is made of mainly from water. So just movement of this water along these fibers can let us visualize these fiber tracts. That's why this is called the advanced version of MRI, because it's not like typical standard one that you saw before. So the tracts that are more important for us in concussion are 5 tracts. So this tract called corticospinal tract, it's actually connecting the surface of the brain, the cortex of the brain, and to the areas that are actually in charge of the motor function. And the other tracts, they're connecting the front and the back of the brain to each other. They're more in charge of the vision. The main tract that is actually found that is really vulnerable to impacts are this tract called corpus callosum that connect 2 sides of the brain, left and right, to each other.
We're looking at a range of different advanced MRI methods, looking at changes in the brain motion, the brain blood flow, alterations in tissue microstructure, alterations in cognitive processes, changes in structural MRI, as well as changes in the brain chemicals.
Dr. Aaron, it's lovely to meet you. Tell me a little bit more about the additional information that you are working on in order to inform this project.
Because the data set is such a comprehensive set, we're cracking one modality at a time. So far we've processed most of our diffusion tractography, quite a bit of mouthguard data, and while the saliva and eyes are about 80 and 90% complete. And once those are complete, I will collate them and perform data analysis.
So you mentioned a mouthguard, how does that work?
So mouthguard has XYZ linear angular accelerator to measure your acceleration, and a gyro to measure your rotational acceleration. We can track the evolution of the acceleration of the head for every single impact. These are the 2 cameras pointed at pupil to detect the pupil motion, and this is the world camera looking at whatever you're seeing. So 2 cameras facing the eye shows you these 2 different video footage, which the automatic segmentation and recognition software shows where the pupil is and the size of the pupil. And all of that data is converted into numbers and exported out to be merged later with other data and compared.
So the ultimate goal is for us to provide tools that can better aid the clinician so that they can provide a more accurate diagnosis of concussion so that they can ultimately develop a more effective care pathway for their patients.